Today on Engineering Newswire, we're developing a guide collar for the blind, creating bionic fingertips for amputees, and eavesdropping on 3D printers. It comes as no surprise that those with limited vision are set to benefit from autonomous cars. However, getting around after exiting the car will still be a challenge. Toyota is working to change this by developing a wearable device for the blind and visually impaired that will provide them with greater independence and confidence. Called Project Blade, the device looks more or less like a toilet seat that wraps around one's neck and shoulders. Despite its odd appearance, the wearable could prove incredibly useful. Equipped with cameras that detect the user's surroundings and communicates information to him or her through speakers and vibration motors, the device can recognize common indoor features such as restroom signs, escalators, stairs, and doors. Users can then interact with the device through voice recognition and buttons. Plus, Toyota plans to eventually integrate mapping, object identification, and even facial recognition technologies. Currently, the development team is asking company employees to submit videos of common indoor features to help them better teach the device to recognize such landmarks. Hopefully, this early stage prototype will eventually provide better mobility for all of those who are visually impaired.
Researchers from the University of California, Irvine have demonstrated that they can steal intellectual property by recording and processing sounds emitted by a 3D printer, which is quite a terrifying revelation for companies trying to protect their intellectual property. The team showed that a device as ordinary as a smartphone can be placed next to a machine and capture acoustic signals that carry information about the precise movements of the printer's nozzle. The recording can then be used to reverse engineer the object being printed and recreate it elsewhere. The scariest part of all, the researchers achieved a nearly 90% accuracy using the sound copying process to duplicate a key-shaped object in the lab. And because many individuals who work on a shift basis at manufacturing plants don't get monitored for their smartphones, this means companies could stand to incur tremendous financial losses. Although there is currently no way to protect these systems from such an attack today, the researchers suggest that engineers could confuse the acoustic signals with additional white noise. Or perhaps just leave the smartphones at home.
A new device developed by researchers from EPFL could allow amputees to rediscover sensation of texture. The device uses a series of sensors to detect undulations in the surface beneath them, converting the physical feel into electric signals. These signals can then be ejected into the nerves of a patient. Amputee Dennis Sorensen recently became the first person in the world to recognize texture using a bionic fingertip connected to electrodes that were surgically implanted in his forearm. Nerves in his fingertip are wired to an artificial fingertip equipped with sensors. As the finger was moved across textured plastic by a machine, the sensors generated an electrical signal, which was translated into a series of electrical spikes that were then delivered to the nerves. In a series of tests, Sorensen could differentiate between rough and smoother textured plastic samples about 96% of the time. The researchers also experimented with non-amputees. The tactile information was delivered through fine needles that were temporarily attached to the arm's median nerve through the skin. These non-amputees were able to distinguish roughness and textures approximately 77% of the time. Although the device obviously promises benefits to amputees, it could also find great applications in the robotics industry.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For the PD&D channel, I'm Kaylee Duffy, and this has been your Engineering Newswire.